Good morning, everyone. Welcome to the Mining Center of Excellence G-Series Off-Highway Trucks presentation. My name is Mike Mesnard. I'm the Off-Highway Truck Application Specialist. Go through a couple of slides here to kick this thing off. Obviously, safety is a big deal, so make sure that you're in a safe area and no exit pass and so forth. And take a look at all the bullets on this slide here as an overview. And obviously safety is first, quality always, and we lead with our values every day. And we always want to win the right way, and again, that's leading with our values and putting safety first. Okay, so again, my name's Mike Mesnard, and I'm the Off-Highway Truck Application Specialist. I covered 770 through the 777 off-highway truck lineup, and been in this role for about 16 years. Here's my contact information. Also, James McKnight, our performance engineer, he's been in this role for quite some time as well, probably about the same amount of time as I have. He's in the live chat, so if you have questions, go ahead and go to that live chat area there, and James can answer pretty much anything you need to know about these machines. One thing I want to really make a point of, too, is that you're going to see probably a little bit more verbiage on these slides, and a lot of that is because this presentation is also kind of a guide. We're going to get into some application stuff towards the last half of it, and you'll be able to download and print this off and kind of use it as a guide. And obviously, you can always reach out to myself if you have any questions related to the trucks specifically or application related as well. This is just a quick overview of what we're going to cover today. We're going to cover the primary truck lineup. We're going to go through a new cab that we're offering on our 773 through the 777, and we'll be talking about, we've got a new seat offering in that cab as well, so we'll be talking about the deluxe versus the premium seat, and general features across the lineup, optimum configurations for application, then taking a look at loading tool alignment, pass matching, and just a couple of key points to keep in mind, and then body selection. Usually there's a lot of confusion around the right type of body for the right type of application. We'll try to cover some high-level bullet points on that, and go over how you go about the process of optimizing the truck. Okay, so here's our lineup: 770G up through the 777. So 40 tons all the way up to 100 tons. That's the truck range we're going to be talking about today. And we're probably going to hit a little bit more on the 777. This is kind of more of a mining-focused event. Usually you're going to see the 777 and the 773 in the mining applications more than the other trucks. But since there's so much similarity across the lineup, I cover those as well. And I've also have other videos out there talking about strategies and so forth on how to look at these machines from a competitive standpoint as well as a comparative standpoint. They're available as well. Okay, so we're going to talk about flexible technology. We did a few changes to the trucks, and it's what we call a positive build as opposed to removing things. You add them, and it's designed around giving customers more flexibility in terms of what kind of features and technologies they want to keep on the truck, or if they want them or they don't want them. But at the same time, if you don't order them from the factory, you can easily enable them through what we call an SEA, or a software-enabled attachment, post-factory. So you can order the truck with whatever features you want. You can add or modify those as well. So, but I'll get into more detail on these acronyms here that you see on the page. But all of these bullet points here are now optional features that you can add as you go through building a truck. some of these things, what we've done is we've tried to make sure that any of these attachments are as easy to install as possible with minimal hardware. So it's easy to go ahead and retrofit these features. So here's kind of like an example of the price list. It shows you, okay, when we talk technology, we're talking mostly information systems, and we used to, it used to be VIMS was our primary information tool. So the way we're offering that now is it's very similar to VIMS. That's called advanced health. So if you have a customer that uses information a great deal in your application, then advanced health is the way to go. If not, if you're not trying to capture productivity information and so forth, then basic health will still give you access to all of the core components that you need to capture off the front. And then here we're talking about the different types of payloads, and there's a lot of confusion on payloads. TPMS, that acronym on trucks, that stands for Truck Production Management System, but it's usually confused with the simple onboard payload. TPMS, it's a complete production management system that captures payload, cycle times, averages, and trends. Basic payload will provide you an onboard payload, as well as can be configured with an exterior payload lights or even a scoreboard on the 777 as of now. But additionally, the basic payload includes a load counter for the operator. So at the end of at the beginning of the shift, they can zero it out, and at the end of the day, it tells you how many loads that they've hauled. And much like a trip odometer in a car, very simple setup. Probably payload itself is the most common request. But again, if you decide at some point you'd like to add the truck production management system to the truck, you can through a software-enabled attachment. It's very easy to do. So in 2020, we put a new cab on the 773, 775, and 777, and those started shipping in the latter half of the year. We call it the G2 cab. And I'll cover a few of those features here in the next couple of slides. The reason it's only on the 73, 75, and 777 is they share a common cab. The two smaller trucks, the 770 and 772, they're on a different platform, and they have a different cab as well. You can see the obvious big change, if you're familiar with the previous cab, is that we've moved the operator's seat back to the left side of the cab. It used to be center of the cab, kind of biased more to the right side in the F series, as well as the previous G series cab. So we received a lot of feedback from operators once we launched this in the F series that they preferred that seat to be back on the left-hand side. So it took a little bit of time to get it there, but we're back there now. And the complaint was that the operator wanted to have better visibility, better positioning to the mirrors to see the sight lines down the top of the body rail, as well as for being able to back up under the loader. So that change has taken place, and this new cab has been received quite well by operators. We also have installed a full-size trainer seat, and I have another slide that will show an overview of some of these features, but it's a full-size trainer seat, and there's also an optional suspension system for that trainer seat. But you can see that on the left or on the right-hand side, that trainer seat, now they have access to that full secondary access egress door, as opposed to the previous cab with the console being placed right next to the right-hand side. You couldn't really use the wind door, is what we call it, the combination of window and door. Now with this layout, it's a lot easier to do. And here's an overview. You can see what the cab looks like from above. But you can see a console in the center that's right next to the seat. That console slides back, so if the trainer wants to come through the driver's side of the cab, they can do that, slide that console back out of the way, and easily access that trainer seat. The other change as well is we integrated the hoist and the gear shift lever into a single lever. The functionality is the same as was before, but now you're just using a finger switch to move the body. The up and down shift buttons function the same on the shift pane. So really there's no change in functionality to this new design. We've also changed the dash. We now have two color touch screens built in. The top monitor is the Waves monitor, or the Wide Area Vision System monitor. And for 777s, that camera system also allows for cat detect. So you can actually have the radars integrated into this system as well. The bottom screen is the touch screen version of the visor, and it's the same thing basically as the visor in the previous cab, but it's just touch screen. So instead of having a physical screen there, it's just like a computer input. The visor also offers a nighttime display, and that allows the operator to minimize the glare at night. And here's something that's actually, this started with the G2 cab as well, and there's been a little bit of confusion on this, but we offer an optional premium leather seat. And the premium seat, not to be confused with the deluxe seat, but the premium seat includes some additional lumbar adjustments. It's both heated and cooled versus heated only, and motorized seat adjustment buttons versus the manual one. The deluxe seat is the standard seat. The premium seat can be ordered via the dealer installed options in the price list. The reason I'm telling you this is because when we first started shipping out the new cab, the premium seat had to be installed because the availability of the deluxe seat was not there at the time. So some customers, they received a free upgrade with the premium seat. So if that happens, just consider it a bonus. We'll also have a comparative sales brand coming up shortly that'll kind of speak to the differences between the two seats and give you a better overview of the functionality. So like I said, these trucks are very similar across the lineup, and these features that I'm going to touch on next, they apply to all of the trucks. And where they don't, I'll let you know. So some of the key features that came out with the G-Series trucks, the primary one was Apex, and this is Advanced Productivity Electronic Control Strategy. And I'm going to touch on all of these a little bit more detail on the following slides. But performance through Apex, then fuel efficiency features through the various power modes, and then of course the information systems that are now optional features that can be enabled with FDA or software-enabled tasks, and also the improved traction control. So Apex, I guess the best way to explain Apex is we're using software to synchronize the shift. If you've ever seen one of the older truck models, they're climbing a grade, and you can tell when they're shifting because the front end of the truck it'll bounce around a little bit. And what's going on is the torque's being dropped down to zero. It's grabbing that next gear and it's bringing that torque up, and it's causing a lot of shift shock to the drivetrain components. The truck's losing speed on grade because now it's dropped out the torque, and it's going to cause more fuel burn because it's going to have to really increase fuel to regain that lost momentum. So with Apex, what we're doing is we're shoving about 60% of that torque right through that shift. So it's minimized a great deal of those issues with respect to loss of momentum on grade, the shift shock to the drivetrain components, and also the ramp up in fuel burn. And across the board, we've seen better fuel and performance for all of these G-Series trucks because of this Apex feature. So obviously if performance matters and fuel matters, which we all know they do, Apex is definitely a key component that helps add to the improvement in cost of tons per hour. Okay, so also fuel modes. There's three main fuel modes. You got economy mode, adaptive economy mode, and power mode, and they're all selected by the switch. It's in the overhead dash area, is shown in the image there. So when the switch is depressed at the bottom, the standard eco mode is enabled. Now, from the factory, it's set at a 10% engine D rate when enabled, but this can be adjusted from 0.5% up to 15%. So if you put one of these G-Series trucks in with some older trucks and you want to dial back the power, you could do that and save fuel. And or if you're just not running really hard, you want to go ahead and derate the power and you're okay with a reduction in cycle times to save fuel, that's an option as well. Most of these applications have a little bit of flex time in their cycle, so it might be something you want to consider when looking at it on application. So when the switch is pushed to the top, that's the adaptive economy mode, and this mode is a little bit more, it's a little more finicky, I guess I could say. It's really looking for stable site conditions. So if that grade has any kind of changes in it that causes the transmission to shift gears, it's not going to set up well and it's not going to perform as well as it could if the application is set up right. So the key to adaptive economy mode is stable grades, stable haul roads, and from that point, then you can go ahead and say, I'm willing to take a 5% reduction in cycle time if I can get an 8% reduction in fuel burn. And then the system will kind of run through and calculate where and when it can apply that. If it doesn't meet those criteria, it won't enable. So it's something definitely you can try on your application to see how well it performs. From my feedback from most operators, most of them are in power mode because they like to have the power they need it. But again, these modes are there. And one thing I would add too is if you ever get a machine on site and it feels like it's not really reaching the full power, check that power mode switch, because there's in many instances it's been accidentally bumped into eco mode and nobody realizes it. It can also be set to a locked position through the advisor screen, so even if you bump it, it doesn't matter. It'll be locked in the mode you select. But definitely keep that in mind. Okay, so advanced health. This is kind of going back to the whole ZEMS discussion I pointed out earlier. This is the equivalent of ZEMS. You're going to get full diagnostic and prognostic information through advanced health if you care to capture that type of information. So it is available, but you'll need to have the technician's toolbox software to capture this data, and you'll pull it off through a cable. You can also get a wireless subscription to Health Equipment Insights if you want to pull some of that data off the wireless. So again, it provides information on what has happened, and also information that kind of could give you a heads up on things that might need to be addressed, like say brake temperatures or something of that nature. But again, you either want advanced health if you care about capturing all this additional information, and if you do want to capture the payload, you can combine those two. You'll have a full suite of production, performance, and machine health information all in one suite. Okay, so this is getting back to the TPMS discussion we had earlier. Again, it's usually confused with onboard payload. So the TPMS, again, it's a full-blown suite of production management tools. You can pull in multiple machines into this feature online, and you can see exactly cycle times, average payloads. You can get a lot of production and performance data out of this ETMS system. If you don't need all that, then you can just go with a basic or standard payload option, and that'll tell the operator what's on board at the moment. And again, also, they have the ability to have a load counter right there on the screen, so they can reset that to 0 at the beginning of the day. And operators love to know how many cycles they've done or how many loads they've done through the day. And at the end of the day, they can zero it out. So it's pretty straightforward. Also, exterior payload lights. That's the red and green light indicators that you see on both sides of the truck platforms. It'll let you know if you're about ready to reach a last pass, or if you're loaded and what pass to stop on. That's also an optional feature. And for the 777, you can get the scoreboard display, which it gives a digital readout externally, so you can see it from outside the truck what the payload is at the time. Now, time mile per hour, this is our tire management system feature. And a lot of people get this confused with tire pressure monitoring. So this does not include tire pressure monitoring. The way this system works and what time mile per hour is, I guess I should explain that first. TMPH or TKPH, whether it's kilometers or miles, but this is a spec that tire manufacturers use to design tire capabilities to make sure you're not exceeding basically the heat capabilities of the tires. So the way we do it is we capture onboard payload, ambient temperatures, and ground speed, and we use that to calculate a real site TMPH number. So when the truck is commissioned, one of the steps in that procedure is to make sure that the technician verifies the tires that are on the truck and pulls that TMPH spec and puts it into ET on the truck. So that's the reference number that is used. So when our TMPH system calculates the real site TMPH, it's going to compare it to the spec TMPH that was put into the system. And it's basically just capturing a moving average of this number. So when that moving average starts to exceed the tire manufacturer's spec, the operator will first get a warning to say, hey, you're exceeding these tire capabilities. And if there's nothing done, well, the second warning is the truck's going to get derated. So tires are a huge deal. It's really important to always make sure you're pulling in your tire professional for anything tire related. We can give you some guidelines and based on the tires that we offer from the factory, but again, what I usually say is once a haul gets out beyond 3 miles each way, I start paying real close attention to tires and what kind of speeds are on the site, payloads, etc. To at least say, hey, look, we need to bring in the tire pros to make sure we're setting this up right. Also, we've got an improved traction control system, and again, this is now optional as well. This can be software enabled. There are a few hardware components that have to be added to the truck, but they're pretty minimal. I believe they're steering center related. But the way this system works is there's a couple of different new features. The first one is it's steering position. It's looking at the front steer tires in terms of where they're positioned to determine if that is causing some of the differential ground speed on the rear wheel. And that's what traction control is simply looking for. It's looking to see if the right or the left rear wheel are going at a different rate of speed. And if they are, it's telling the system, hey, look, we've got a slip situation here. We need to apply brakes to the slipping tire and put that torque back over to the tractive tire. So the first thing it's going to do now on this new G-Series system is it's going to look to see the position of the steering wheel, the front steer wheel. If they're cranked hard and the truck's doing a circle, well, naturally the ground speed on those two rear wheels is going to be different. If it's just partially turned, the traction control system will accommodate and apply that traction on a pro rata basis, depending on where how those front is. Additionally, instead of using the park brake side of the system where we're using accumulators to apply the brakes, now we've plumbed this traction control system into the service brake side of the braking system. So it's a lot quicker response, and it can also respond at a lot lower ground speed. And again, the idea is to get, to address a slip situation as quickly as possible, get the torque applied where it needs to be, and get the truck moving as rapidly as possible. And that's kind of what this system was designed to do. Okay, so now we're going to talk about optimum truck configuration. What is optimum? How do you go about calculating target payload? And then body selection. There's a lot of confusion in how this all works, and these are just rules of thumb that I use. Some people might do it differently, but when I'm looking at how to set up a truck and optimize it, I'm always thinking of weight versus durability. Just because you have a lot of steel in a body, you might get a lot of body life out of it, but for instance, on a 777, some of those liners can be, 15,000 pounds or heavier. So you're hauling around 7.5 tons of steel that, it's extending the body life, which is great, but in many instances, you're not getting paid to move steel in the body. So the way I look at an optimum configuration is we want to try to get that lowest machine empty operating weight so we can put the highest payload in there. And I'm going to touch on that here in another slide, how you go about calculating target payload. And again, the body, that's the largest component here, and that's why we want to look closer at the body. All the other features combined on a 777 size truck don't amount to maybe 2,000 pounds. So the thing that's going to move the needle on truck empty weight is going to be how you configure that body. For most of the haul trucks, the smaller trucks, 775 on down, the quarry body in most applications is the optimum body. And for the 777, I would say from a weight standpoint, if you're in overburden or you're moving limestone or soft material, the medium duty X body is a great optimized body. And I'm going to cover each one of these bodies here in a few slides. So here's the age-old, argument: is dual slope better on steep grades, or is the flat floor? And how do you go about answering that question? And the typical claim for being in favor of a dual slope body is material retention on steeper grades. And theoretically, this might be accurate at some point, but for most off-highway truck applications, it's not really relevant. And the reason why I say that is the angle of repose, or basically the base body floor angle when the truck is on a level surface, is 13 degrees sloping forward. So when you convert that degrees to percentage of grade, that's almost a 23% grade. So before the slope of the floor even becomes an issue, you're not going to run these off-highway trucks on 23% grade. It happens every once in a while. It's just not an optimum scenario to run these, because you're probably going to spend a lot of time in torque converter drive and burn a whole bunch of fuel if you're flying a grade like that. And our brake slope holding capabilities are set at 15% grade. So it's just not optimum. The system's not set up for a grade that steep. So hopefully this makes sense. But until you get to a 23% grade, that floor is not even going to be angled backwards, so towards the rear. So it's irrelevant. The advantage of the flat floor, or what we call a quarry body, or even the X body, is it's just flat. It has a lot fewer wear points. It's easier to meter material. When you compare that to the dual slope, it has an additional 18-degree dovetail that kicks up on the tail of the body. That kind of creates a surge when you're going into dump mode. You reach a certain level, and then that material will stop, and then you put it up a little bit further, and it's going to surge out. You won't get that on the X body or on the Corey body. Again, those are just flat floor bodies. So how do you go about calculating target payload? Well, the easiest way to do this is you go into the back of the spec log on the specific model you're looking at, and you can look at how the truck's configured. Say you have the X body, medium, lined body. There's a table towards the back of the spec log that will tell you exactly what that, what that target payload should be. But how do we go about calculating it? Well, the main thing to understand is gross vehicle weight. That's a fixed number. That's the number you can't go over. So, again, talking to empty machine weight being critical, the less the weight of the machine that's rolled up into that GVW number, the more that is left for payload. So that's why optimizing via selecting the right body is so critical. Again, I understand body life is obviously key as well, but we've got to find a balance in there. You can take a look at what it costs you on a cost per ton basis to carry, 5 or 6 tons of steel around all day long, and you can calculate a payback on that and see where, how this pencils out in terms of body life versus the weight of the body. And again, here's that table I was talking about. Again, back in the payload or the spec log towards the rear, the weight tables will be in there, and there's a payload section at the bottom. You can actually look at highlight the different body volumes. You can see those, and then this down here below also calculates the optimum density based on a target payload, based on maximum payload, and then 120% max not to exceed. And I'm going to cover the 10-10-20 policy here on the next slide just to clarify that. So there's a couple different ways that people read the 10-10-20 policy, and what it actually means is 10% of the time you can exceed 110% of what we call target payload. And at no time can you exceed 120%. Another way to look at this is 90% of the time you want to stay below 110% of target. And you want the average of those payloads to be as close to target payload as possible. I mean, that's the ideal scenario. That's where the truck's going to be most optimized on fuel, et cetera. So, again, there's a lot of things that go into that: grades, material densities, the bucket size, the loader, pass match. All those things are going to come into play in terms of how the payload's going to stack up on these trucks. But to me, the main thing is you want to try to stay away from 110%. In some instances, you might find that maybe you can't really ideally get right at target. Maybe you're going to find that with the bucket you have and the density you have and the loader alignment, maybe you're around the 104, 105% range. To me, that's just a business decision. As long as you're staying away from exceeding that max 110%, that's the rule of thumb I use. And just forget about 120% max. You don't want to go anywhere near that. So if everybody involved does their job right, we should be looking at loader buckets, looking at densities, and volumizing the body correctly through sideboards or whatever features we need to add to make sure that we're getting as close to a target payload before it optimizes that truck. So hopefully that helps you explain a little bit on the 10-10-20 policy. I know it's confusing. I give have a lot of classes where I ask people about this policy, and everybody's heard about it, but people have a hard time explaining it. So that's the gist of it right there. And again, like I said in the beginning of this thing too, I know there's a lot of verbiage going on in here, but this presentation is a really good reference tool. You can download this and print it off, and you can use it as a reference guide. So I apologize for all the verbiage, but again, there's a lot to cover. So I want to make sure that this is something that can be useful to you after this event. So what is a quarry body? I mean, it essentially is what it is it's a flat floor body. So the difference between the quarry body and a typical flat floor body is you don't put a liner in this. Instead of having a 20 mil floor plate and then adding, say, a 16 mil liner, which gives you a total of 32 mil of steel, the quarry body is just a single 25 mil floor plate. It also has heavier sidewall and front wall thicknesses of the unlined body. But the goal here, again, is it's back to optimization. And the quarry body for 775, that's probably the predominant body that you see going out on 775s and also 772s. And what does it do? I mean, you now have a body that's going to last, you're going to get good life out of it in limestone. And, if you're working with granite, you want to take a look at going with like a flat floor lined body or a dual slope lined body. Or in many instances, we'll see those bodies rubber lined in granite. But if you're not in a really hard abrasive material, something softer like limestone, you'll get excellent life out of a quarry body. And you've also shaved 2.5 tons off the machine empty weight. So now you can put payload, volumize the bucket on that loader to hit payload, push that payload a little bit harder. And it's called payload for a reason. I mean, it's money. So we want to maximize the amount you can get in. Again, these tables are at the back of the spec log. So what's the X body? To be honest with you, I'm not sure where the nomenclature came from of the X body, but it's just a flat floor body. And what it really is engineering designed this body to not only work as a flat floor body, but also to function very similar to what the dual slope body would when a tail extension was involved. So if you added a tail extension onto the dual slope body, it kind of works like an X body from a volume standpoint. So now you go from having a 78-yard body on the dual slope body up to 83 cubic yards of volume on the X body. And of course, you can sideboard it, and that'll get you close to 90 yards. And usually you won't need any type of a tail extension on this body, but it's available if you need to utilize it. But again, you're immediately adding another 5 yards of volume to the body. It's also just a little bit lighter than the dual slope lined body, so now you can get more payload on the truck. You have the volume to do it with. You'll have more flexibility in terms of loader alignment, bucket size alignment. There's just a lot more flexibility by having this body on the truck. And again, I mean, if you're in the softer materials, if you're stripping, overburden, if you're running in limestone, this body will be fine. Now we also have a heavy duty version, and the body's just going to get heavier. So if you're in more of an abrasive material, or if you're in larger fragmented material, or granite or marble or something like that, then you could go with the heavier line body. Again, I mean, driving to the X body, I think, is where we're taking this, primarily because of volumization of the body and, loading tool alignment as well. You get into a lighter materials, a 2,600-pound material like limestone, you'll have a hard time getting the target payload with the 78-yard volume on that body. So the X body lines up perfectly from a volume and density range. So just keep that in mind. Okay, I think I went over this slide. Anyhow, here's a few. You can see a photo of what the X body looks like. There's the flat floor image there. And you might say, okay, how do I know if a truck already has an X body on it? It's real easy to tell. That first bottom left image is an X body, and the bottom right image is the typical dual slope body. And the dead giveaway on the X body is you have those vertical side supports on the body. If you see those, that means you have an X body on there. So just a little heads up on how to determine one. Okay. So now pass match. I mean, there's a lot of confusion to this as well. I mean, you've got pass match charts out there, and they give you a pretty good general idea of how that works. But I'm just going to hit on a few things that I look at when I'm setting up a truck and thinking about loader alignment. So one thing is loaders usually use a heavier density to get to the loader rated load. So usually they're using 3,000 pound material to get the rated load on, say, say 988. That's a 12.5 ton loader. You're not going to get to 12.5 tons in a 10-yard bucket in 2,600 pound material. You're just not going to do it. But the truck bodies are sized closer to that density range, 2,550 pounds up to 2,800 pounds. Depending on how you have that body configured, the density is going to vary to get to target payload. So the generic pass match charts that you see, like this one on the screen here, they do get you a general guideline to, okay, 4 pass, 3 pass, 5, whatever it lines up to. The chart generically works, but I think you have to go to another level of detail, and you want to pull in the density and the loading tool, bucket sizes you're using, estimated fill factors, all those kind of things. And, those things are best determined by getting one of us application folks on site and letting us do density tests, bring in some scales, do some scale studies to see exactly what kind of payloads you're getting. And there's a lot more to setting up payload, and it might not seem like much, but we can tweak things and maybe change that payload by a ton or two. But if you're doing 3 or 4 cycles an hour, running 6,000 or 7,000 hours a year, that adds up pretty quick. And those are the kind of things we do when we bring out our scale truck. So always reach out to us if you need assistance on that. We love running the scale truck. So again, on pass match, the key points that I look at is, okay, bucket volume to body volume. And again, this is just how I do it. I know there's a dozen ways to do this at least probably, but to me, you want to look at to make sure your loader bucket volume and your body volumes align first. And the density is going to kind of take care of itself. You want to obviously make sure you're not overloading the loader or overloading the truck either way, but you start off at the bucket and body volume alignment, and then you work from there. And if your density is too light, add sideboards, and then take a look at that, to see if the bucket on the loader is still the right loader, the right bucket, or if you need to maybe go to a larger bucket. Again, those are things you want to consider. And you also want to always keep an eye towards making sure you're not exceeding the loader capabilities or the truck capabilities. Many times you're going to see density is a little bit light to actually reach target. The only way to get there is adding volume to the body. If you just add volume to the body without impacting, without doing some modifications to the loader, you're really not changing. So it just kind of, again, you have to pull in both the loader and the truck if you want to maximize it. And to me, many times these sites, most sites aren't super efficient to where you can't afford to do an additional pass. And sometimes you'll see that, maybe you go a little bit smaller on that bucket, you get another pass in there, but the way the volume lines up, you're actually getting more payload on the truck. And especially on an inefficient site where the truck might sit for a little bit at one end or the other, if you're maximizing payload every time it goes down the haul road, well, that's the best you can do. That's about as efficient as you're going to get. So that's the way I always accept it. So in summary, there's a new cab on the 773, 5, and 777. We have an optional premium seat upgrade that can be retrofitted by the dealers. All information systems are now software-enabled attachments, so they're optional. And keep in mind, if you don't put them on the truck from the factory, you can add those post-factory. Target payload is basically gross vehicle weight minus empty machine weight as configured. And then there's the configuration weight tables are in the back of each machine's respective spec log. Remember, one thing I really want to drive home about this weight roll-up, most of our competitors do not put body liner weights in their spec. So if it shows on the front of their spec log that it's say 100-ton truck, by the time you add that 16,000 pound liner, it's really going to be closer to a 92 to 93 ton truck. When we build up our weight tables, we're including these weights. So make sure if you see any competitors' information, make sure to ask, hey, does this weight include the liner weight of the body? Because you really need to know what that machine is going to weigh. empty so you can make sure that you're not overloading, especially in downhill loaded applications where braking and steering becomes critical. If you're in an overload situation, you don't know it, and it's a safety issue. So you want to make sure when you're talking trucks that, not only competitors, but us as well, you want to make sure you understand how these target payloads and weight roll-ups work. And again, optimize the body if you want to maximize payload. 775 and down, use the quarry body unless you're in granite. Other than that, you can use a dual slope if you want to. It really doesn't help in terms of material retention. So the quarry body optimizes the machine weights and allow you to push payload. On the 777, X body with medium duty set aligners will work very similar to a quarry body. Again, optimizing empty machine weight, maximizing payload. So pass match, align the bucket and the body volumes, then work backwards to confirm you're not overloading the truck or the loader. And then the 10-10-20 payload policy is a guideline. If you're not hitting exactly target, it's okay, just as long as you're not overloading the truck. If your goal is to hit target and you want to optimize the machine, then you got to work to see that your loader and your truck are both optimized as a system to see that they get you close to that target. But if you're playing a little bit over target, 103, 105%, you're safe. And like I said, look at 110% of target as the max and forget about 120%. If you do that, you should be fine. And also keep an eye out for holes longer than 3 miles one way. Again, this gets back to tires. So when you're thinking about trucks, you got to think about hull distance. You got to think about material density, body volumes, bucket sizes, gradability, and all those things. So it's perfect setup for whenever you're putting these machines together. Just those are the 4 or 5 bullets you need to be aware of. Okay. First, another point, just make sure, if you could, please, when we're done here, to stick around for the survey. That allows us to get feedback and see if what we're doing is addressing all of your questions or concerns. And I guess now we'll just open it up for questions. I want to thank everyone for participating in today's presentation. And again, here's all my contact information. You can reach me on my mobile phone anytime. My desk phone rolls to my mobile phone, so it doesn't matter which one you call. My email address is there, and James is there as well. So hang on, we've got a question in here about pass match, 992 pass match on the 777. Well, again, it depends on how you volumize the body. You got the 16-yard bucket, which is probably the most common, and you also have a 17-yard, and I believe the 992 has a 19-yard bucket for lighter material. I'd say 16 is probably the optimum. If you go with the X body, I'd add the 7-inch sideboards to that, and you can take that 17-yard bucket and get close to a 5-pass on there. And again, this depends on density. The 992, the high lift, I believe, is a 21.5-ton loader. So getting to 21.5 tons in lighter density, is going to be a challenge. But if you're at 3,000-pound material density, you're pushing the rated load of that loader. But I would say 16 to 17 yard is optimum. So you're looking at a 4 to 5, maybe 6 pass match again, depending on density. Let me see here. I think maybe I'm missing the Q&A. Let me jump into the Q&A segment here and see this. Okay. James, what exactly do I need to take a look at in here in terms of Q&A that needs to be addressed? New question. There's one new question here. You could use that 19-yard bucket in 2,800-pound material. Again, body volume is going to matter. It's a 4-pass setup, so that'll hit perfectly with the dual slope body, so that's not a problem there. Again, but if you're going up against say our competitor's 100-ton truck, that 19-yard bucket's great. You 4-pass with 19, and depending on the material density, 2,800 pound. I can't do the math in my head, but if you go to that X body, you go to 83 yards. You hit that 17-yard bucket, you'll do a 5-pass. You won't get 4, you'll get 5, but you'll push that payload because the 17-yard volume at 5-pass is going to get you closer to 85 yards of material. So again, if your sight is not running like a Swiss watch, which very rarely do I see them running that way, you just got to run the numbers and say, hey, does it make sense for me to 5-pass this with a 17 versus 4-pass with a 19? Every time that truck goes down that haul road, it's going to be carrying more payload. And to me, that loading tool optimizing the truck payload is key. So again, it is another pass. And those conditions, it really depends on the application. But to me, I'm a truck guy. I want to push truck payload as close as I can to that optimum payload. And again, there's a lot of variables involved to taking the pass match. But generically, if you look at it from a volume match standpoint, that you can use an 19. What else do we have here? Okay, so the cooling in the seat, James, I don't know if you answered that or not, but hang on here, I got a couple things going on. What it is, there's a cooling system in the seat. It's very similar to the system you'd see in a car. It just cools the seat or it heats it. It's just a different component on the premium seat versus the deluxe seat. Technically, how to answer that, I'm not sure. Maybe James might have an answer for that. I apologize. It's hard to see all these questions that come into it. Trying to make my screen. Okay, let me see here. This is kind of a long question. Okay, so if you can estimate TKPH or TMPH, there will be a way to estimate the rolling resistance. I don't know. That's a good question. I've never been asked that particular question right there. But one of the rules of thumb we use in the Performance Handbook, and if you don't have the Performance Handbook, I keep that thing handy all the time, but there's a rule of thumb if you want to be able to calculate rolling resistance. You go and you look at the tread pattern and how far it's digging into the haul road. And for every inch of depth, you want to add an additional 1.5% of rolling resistance with a baseline of about 2.5%. So no matter what, if you're setting on a flat concrete parking lot, your rolling resistance is going to be about 2.5 to 3%. So if you're another inch depth, tread depth into the haul road, add another 1.5, and you're going to be, 4 to 4.5% rolling resistance. So that's the way we usually look at that. In most typical applications where the road's well maintained, you're probably looking at about a 3 to 4% rolling resistance. But I've seen them really, really bad. We've been to some places in South America where I've seen, mud in some instances come well up to up easily over the rim, the bottom part of the rim on the tire. So you're looking at probably a foot or so of tread depth. So it's all over the place. But that's, to me, the rolling resistance calculation is best done that way. Yeah, and there's a question on here about the new hoist and shift joystick only with the new cab. That's correct, yeah. And it's not available in the 770 or 772 at this time. Some of these features are available on the 777E. we've upgraded the 777E. We're in the process of doing that. I believe it's out there by now. I can reach out to my counterpart in APD, but Apex should be on the E now, as well as the traction control system, I believe. But I can confirm that if you want to send me an email directly. I can double check on traction control. Sorry, I didn't have a whole complete answer for that. So what is the best using standard economy mode only, or loaded condition on, or only for empty condition? Is there any standard or best practice for using economy mode? I think the best rule of thumb for using economy mode is if you put a G-Series truck in with some older trucks and you see that the G-Series truck is always right on the tail of the other trucks, maybe you could go and start adjusting the D rate down a little bit to let it line up a little bit better with the rest of the fleet. That might be the best example of when to use eco mode. Again, most of the time customers or operators like to use power mode, so if you don't lock them out of it, they're going to put it in there anyhow. But that's how I would recommend using eco mode. Or again, if you're seeing a lot of delay time at the where you're dumping, or there's a lot of delay time in the load area, maybe put it in economy mode and play with that D rate adjustment until it works for you, for sure. And then track the fuel and see if it helps. It should. One thing to keep in mind: the steeper the pit, the higher the fuel burn is going to be on these trucks. So, and that applies to any truck. The more it spends time in the bottom end of that lug curve on the engine, the deeper it's going to, the more fuel it's going to use. So that will play a part as well into eco mode. So if you're on a relatively flat haul, a flatter haul, eco mode might be great. But if you're really pulling a grade, I don't know. You'll have to check and see the trade-off between cycle times and speed. The DSS, the driver safety system, yes, it is available for the 777 trucks. There's a different group that manages that, but it is available. And I think that, let me see, I got 3 more questions up here. Again, when you talk about, the question is, how can 777G drop torque during shifting? Looks like James is going to answer that. And again, it has something to do with synchronization, but James will be the authority on the response here. He's the one that actually told me how this all functions. So. And the other question here is from SoTrek, and I am no good at Spanish or Portuguese. I apologize. So I might have to have Pablo or somebody help out on that one. Yeah. So we're coming up on the end here. Again, everybody, here's my contact information on the screen, my email address, my phone number. So please don't hesitate to reach out to me if there's questions you have beyond this, or if you need help configuring a truck or a system approach. If I can't answer it, I definitely have the resources to find the right folks that can. So, and again, download this thing and use it as a guide if you need to. I have multiple other tools like this that you can use. So please reach out to me, and thanks again for participating. I really appreciate it. Have a good day.